Chapter 6, Lesson 5, Algebra Properties. You will be able to use properties to simplify expressions. Properties are statements that are true for any number. The expressions 6 times 10 and 10 times 6 are called equivalent expressions because they have the same value. This illustrates the commutative property. So we have three properties we're going to talk about today. The first one is the commutative property. Now there's a commutative property of addition and a commutative property of multiplication. And what it states is that the order in which two numbers are added or multiplied does not change their sum or product. So in other words, 7 plus 9 is the same as 9 plus 7. Similarly, 4 times 6 is the same as 6 times 4. So the numbers can switch around when you add or you multiply, and it will not change the sum or product. The associative property states that the way in which three numbers are grouped when they are added or multiplied does not change their sum or product. So again, we have three numbers being added over here, 3, 9, and 4. The first two numbers to be added are in the parentheses, 9 and 4, and then the 3 added after. Well, 9 plus 4 is 13, plus 3 is 16. Over here, the 9 and the 3 get added together first, which is 12, plus 4 is 16. So when you're adding, it does not matter where the grouping symbols are. Same thing with multiplication. When you multiply, it doesn't matter which order you multiply. Identity properties state that the sum of an addend and 0 is the addend, and the product of a factor and 1 is the factor. So what you put in, you get out. So if you are looking in the mirror, you will see yourself. So 13, when it's being added to 0, what comes out is itself, 13. Same thing with 7 times 1. When you multiply 7 by 1, you get 7 in return. You get the same thing you started with. Those are identity properties. Determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. So we have two expressions here. Let's do 15 plus the quantity of 5 plus 8. We do 5 plus 8 first, which is 13. Bring down the plus 15, and 15 plus 13 is 28. On the right-hand side, we do 15 plus 5 first, which is 20. Bring down the plus 8, and 20 plus 8 is 28. These two are equal, and the thing that was different from the first and the second were the grouping symbols. So this would be the associative property. And this would be of addition, because we are adding. Letter B. (20 minus 12 is 8. Bring down the minus 3. 8 minus 3 is 5. And on the right, 12 minus 3 is 9. Bring down the 20 minus. And 20 minus 9 is 11. These two are not equal. And that symbol right there, the equal sign with the slash, means not equal. So now we have to explain why. So this is not true because it's trying to show the associative property here, because we've got our parentheses changing, our grouping symbols changing. So our explanation would be that the associative property does not apply to subtraction. Your properties only apply to addition or multiplication. Letter C. 20 divided by 5, or 5 divided by 20. Oops. Well, 20 divided by 5 is 4. And 5 divided by 20 is really 5 over 20, which can be reduced to 1/4. So these two expressions are not equal. Now what I see here is them trying to show the commutative property where the order changes. So the reason it doesn't work is that the commutative property does not apply to division. Letter D. 13 plus 0 and 34. Well, 34 plus 0 is 34, and 34 is simply just 34. Those aren't equal. So what this is showing here is the identity property. And this is of addition. It's identity because the 34 we started with, and we ended up with the 34 at the end. So 34 is the same as 34. It is the identity property of addition. Letter E. First we do 6 times 3, which is 18. Bring down the 5. And 5 times 18 is 90. On the right-hand side, 5 times 6 is 30. Bring down the times 3. And 30 times 3 is also 90. They are equal. The grouping symbols change, so I know that this is the associative property of multiplication because it's multiplication. Letter F. 27 divided by 3 is 9, and 3 divided by 27 is 3 over 27, which reduces to 1/9, and these are not equal. It looks like they're trying to show the commutative property because the order changes. So again, here we have the commutative property. Does not apply to division. Randy earned $7 babysitting and $12 cleaning out the garage. Write 2 equivalent expressions using the commutative property that can be used to find the total amount she earned. Well, to find the total amount, you add them together. So 7 plus 12. If we're using the commutative property, that means we can switch them around. So it'd be 12 plus 7. And it doesn't say we have to simplify, it just says to write the equivalent expressions. So that's our answer. Letter C. The area of a triangle can be found using the expression 1/2 times b times h, where b is the base and h is the height. Find the area of the triangle below. So 15 right here is the base, and 12 is the height. Area equals 1/2 base times height. Area equals 1/2 times 15, which is our base, times 12, which is our height. Now, I could find half of 15 and get either a decimal or a fraction, or I can use the commutative property and switch around 15 and 12, and then find half of 12. So let's use the commutative property here. Area equals, let's do 1/2, and let's switch 12 and 15. So 12 and 15. So then we have multiplication and division from left to right. 1/2 times 12 or half of 12 is 6. Bring down the times 15. And 6 times 15 is 90. So our area is 90, and it would be square feet. Letter D. Vicki earned $6 an hour while working 11 hours over the weekend. She put 1/3 of what she earned in a savings account. Find out how much she put in the account. So to figure out how much she earned, we would do 6 times 11. And then we would want 1/3 of that. Well, I could do 6 times 11 and find 1/3 of that. Or instead, I can use the associative property and do 1/3 times 6 and then multiply it by 11. And 1/3 of 6 I'll do over here on the side. 1/3 times 6 over 1 is 6 over 3, or 2. So I have 2, bring down the times 11, and 2 times 11 is 22. So she puts $22 in the account. So we can use the properties when we solve our simple word problems here. We can use the properties to help us solve it a little bit more quickly, to help us use a little bit more mental math.